Hello, Jaguar students. It's your friendly neighborhood math teacher, Mr. Allred, and we're going to talk about our last mini lesson in Unit 10. We're going to talk about a lovely, lovely thing called mean absolute deviation. Okay, we call it MAD for short because this is really going to make you mad. I'm not going to lie to you. It's pretty outstanding mathematics that's about to happen to you today. You should be able to explain MAD to a friend by the end of the day today. Okay, we're going to go ahead and get started with the notes. Okay. Way back when we started Unit 10 2 days ago, we said that there were two different ways to describe a set of data. We said we could describe it categorically or numerically. Today we'll focus on numerical descriptions. Numerical data is when you ask questions that have numbers for answers. Okay. Whenever you ask a question that has a number for an answer, you're going to get lots of different numbers, hopefully, and you'll have a data set. When you have that data set, you can find the mean. That's the average of that data set. You could even find the median, that's the middle number, in an ordered data set. Okay, those are measures of center. Measures of spread would describe how different a set of data is. Okay, the range is the biggest number minus the smallest number, and our quartile range is the upper quartile minus the lower quartile. These are all things we talked about before. We talked about measures of center one day in mini lesson 1. We talked about measures of spread the second day in mini lesson 2. Measures of spread tell you how different a data set is, how big some of the numbers are compared to how small they are. But measures of center tell you what the average is or what the median is, how the average person did. Today, we're going to talk about mean absolute deviation, which really brings them all together. Okay? It's a numerical measure of spread that shows how much data values vary from the mean. So it's going to talk about the center and the spread of the data. Okay? If you have a very low mean absolute deviation, that would tell you the data points are pretty close together. Okay? They're pretty typical. If you have a high mean absolute deviation, that would tell you that the data points are pretty far apart. Okay? Maybe they're not as consistent. Okay? What I'm going to do is I'm going to look at one example with you, and then I'm going to talk about another one with you. Okay? To find mean absolute deviation, the first thing you're going to do is find the mean of a data set. Okay? First thing you're going to do is find the mean. Okay? The second thing you're going to do is you're going to take each number in the data set and subtract it from the mean. So you can figure out how different it was from the average, each number. Okay? If the average on a test was 75 and little Billy made a 65, he would be 10 away from the average. Then you're going to find the absolute value of each difference. So you might have some negatives and some positives. That's just so we can make them all positive with absolute value. Then we've got new numbers now, all the absolute values. We're going to find the mean of those new numbers, of the new data set. And that's going to tell us the mean absolute deviation. It's the average of how far numbers are from the average. That's right. I'll say it again. It's the average of how far away the numbers are from the average. Okay. The first thing you need to do, because your chart does not have this, is I want you to fill in these data points right here. They're on this chart: 1, 2, 4, 8, and 10. First thing we're going to do is step 1. We're going to find the mean. 1 plus 2 plus 4 plus 8 plus 10 is 25. And 25 divided by 5 is 5. There are 5 data points. Added them all together and got 25. 25 divided by 5 is 5. Now I'm going to take each number and subtract it from the mean. 1 minus 5 is negative 4. 2 minus 5 is negative 3. 4 minus 5 is negative 1. 8 minus 5 is 3. 10 minus 5 is 5. See how I took each number and subtracted the mean from it? I said it for every number in the data set. Okay? Now I have some negatives and I have some positives. I'm going to find the absolute value of all those numbers. Absolute value of negative 4 is positive 4. Absolute value of negative 3 is positive 3. Absolute value of negative 1 is positive 1. And then you got 3 and 5. Now you have 5 new numbers: 4, 3, 1, 3, and 5. You're going to find the average of those new numbers. 4 plus 3 plus 1 plus 2 plus 5 is 15. And 15 divided by 5 is 3. So the mean absolute deviation, the average of how far away those numbers are from the average, is 3. That wasn't too terrible, was it? If it was, go back about 2 minutes ago, rewind it, and watch it again. All I did was I took the numbers in my data set, I found their average. Then I subtracted each number in the data set from the average. Then I found the absolute value of all those numbers, and then I found the average of my new numbers. Okay? Just like it says up here in this chart, it's the measure of spread that shows how much data values vary from the mean. So on average, those numbers are about 3 apart from each other. Okay, that means that they were pretty close to each other. It was a pretty consistent data set in comparison to some other ones. Okay, what we've got here is we've got a situation where we've got 3 different students. We've got Lee, we've got Bessie, and we've got Jamal. And your objective is you're going to try to figure out which one the best student is. Who is the best student? When you look first at that chart, okay, who do you think the best student is? Is it Lee, who made a 65, an 82, and a 93, and a 100? Is it Bessie, or is it Jamal? Look at their scores and try to think about who you think the best student would be. Take a few minutes to pause your video, talk about it with your partner, and then put your answer on Edpuzzle when it asks you about it. Okay? You're going to take Lee's scores, his 4 scores. You fill them in Lee's chart right here in this column. You're going to take Bessie's score and put them in this column, Jamal's score and put them in this column. And your objective is going to be to find the mean absolute deviation for each student. That might tell you who the best student is. It might not. It kind of depends on what your opinion is. But we're going to look at those 3 students and find their mean absolute deviation. Take a second to copy down their numbers into each chart. Okay? And that's really the end of the video. When you come to my station, you'll either have already finished this already, hopefully, and we can look at it, or we can look at this part together with Lee, Bessie, and Jamal. Okay? And whoever you think the best student is. Thanks for watching my video. Have a great day. Thank you.